the substance of things unseen, cities past and future. In Oxford, perhaps we can use Lewis Carroll and look in the looking glass that is New York City to try and see our true selves, or perhaps pass through to another world. Or in the words of F. Scott Fitzgerald, as the moon rose higher, the inessential houses began to melt away until gradually I became aware of the old island here that once flowered for Dutch sailors' eyes, a fresh green breast of the new world. My colleagues and I have been working for 10 years to rediscover this lost world in a project that we call the Mannahatta Project. We're trying to discover what Henry Hudson would have seen on the afternoon of September 12, 1609, when he sailed into New York Harbor. And I'd like to tell you this story in 3 acts, and if I have time still, an epilogue. So Act 1, a map found. So I didn't grow up in New York. I grew up out west in Sierra Nevada mountains like you see here, and in Red Rock canyons. And from these early experiences as a child, I learned to love landscapes. And so when it became time for me to do my graduate studies, I studied this emerging field of landscape ecology. Landscape ecology concerns itself with how the stream and the meadow and the forest and the cliffs make habitat for plants and animals. This experience and this training led me to get a wonderful job with the Wildlife Conservation Society, which works to save wildlife and wild places all over the world. And over the last decade, I traveled to over 40 countries to see jaguars and bears and elephants and tigers and rhinos. But every time I would return from my trips, I'd return back to New York City. And on my weekends, I would go up, just like all the other tourists, to the top of the Empire State Building, and I'd look down on this landscape, on these ecosystems, and I'd wonder, how does this landscape work to make habitat for plants and animals? How does it work to make habitat for animals like me? I'd go to Times Square, and I'd look at the amazing ladies on the wall and wonder why nobody's looking at the historical figures just behind them. I'd go to Central Park and see the rolling topography of Central Park come up against the abrupt and sheer topography of Midtown Manhattan. I started reading about the history and the geography of New York City. I read that New York City was the first megacity, a city of 10 million people or more, in 1950. I started seeing paintings like this. For those of you who are from New York, this is 125th Street under the West Side Highway. It was once a beach, and this painting has John James Audubon, the painter, sitting on the rock, and it's looking up on the wooded heights of Washington Heights to Jeffrey's Hook, where the George Washington Bridge goes across today. Or this painting from the 1740s from Greenwich Village. Those are 2 students at King's College, later Columbia University, sitting on a hill overlooking a valley. And so I'd go down to Greenwich Village and I would look for this hill, and I couldn't find it. And I couldn't find that palm tree. What's that palm tree doing there? So it was in the course of these investigations that I ran into a map. And it's this map you see here. It's held in a geographic information system, which allows me to zoom in. This map isn't from Hudson's time, but from the American Revolution 170 years later, made by British military cartographers during the occupation of New York City. And it's a remarkable map. It's in the National Archives here in Kew, and it's 10 feet long and 3.5 feet wide. And if I zoom in to Lower Manhattan, you can see the extent of New York City as it was right at the end of the American Revolution. Here's Bowling Green, and here's Broadway, and this is City Hall Park. So the city basically extended to City Hall Park. And just beyond it, you can see features that have vanished, things that have disappeared. This is the Collect Pond, which was the fresh water source for New York City for its first 200 years, and for the Native Americans for thousands of years before that. You can see the Lispenard Meadows draining down through here, through what's Tribeca now, and the beaches that come up from the Battery all the way to 42nd Street. This map was made for military reasons. They're mapping the roads, the buildings, these fortifications that they built, but they're also mapping things of ecological interest, also military interest, the hills, the marshes, the streams. This is Richmond Hill, and Monetta Water, which used to run its way through Greenwich Village, or the swamp at Gramercy Park, right here, or Murray Hill, and this is the Murray's house on Murray Hill 200 years ago. Here's Times Square, the 2 streams that came together to make a wetland in Times Square as it was at the end of the American Revolution. So I saw this remarkable map in a book, and I thought to myself, you know, if I could georeference this map, if I could place this map in the grid of the city today, I could find these lost features of the city in the block-by-block geography that people know, the geography of where people go to work and where they go to live, and where they like to eat. So after some work, we were able to georeference it, which allows us to put the modern streets on the city, and the buildings, and the open spaces, so that we can zoom into where the collect pond is. We can digitize the collect pond and the streams and see where they actually are in the geography of the city today. So this is fun for finding where things are relative to the old topography. But I had another idea about this map. If we take away the streets, and if we take away the buildings, we take away the open spaces, that we could take this map, if we pull off the 18th century features, we could drive it back in time. We could drive it back to its ecological fundamentals, to the hills, to the streams, to the basic hydrology and shoreline, to the beaches, the basic aspects that make the ecological landscape. That if we added maps like the geology, the bedrock geology, and the surface geology, what the glaciers leave, if we make the soil map with the 17 soil classes that are defined by the National Conservation Service, if we make a digital elevation model of the topography that tells us how high the hills were, then we can calculate the slopes, we can calculate the aspect, we can calculate the winter wind exposure. So which way do the winter winds blow across the landscape? The white areas on this map are the places protected from the winter winds. We compiled all the information about where the Native Americans were, the Lenape, and we built a probability map of where they might have been. So the red areas on this map indicate the places that are best for human suitability on Manhattan, places that are close to water, places that are near the harbor to fish, places protected from the winter winds. We know that there was a Lenape settlement down here by the collect pond. And we knew that they planted a kind of horticulture, that they grew these beautiful gardens of corn, beans, and squash, the Three Sisters Garden. So we built a model that explains where those fields might have been. And the old fields, the successional fields that go. And we might think of these as abandoned, but in fact they're grassland habitat for grassland birds and plants. And that they become successional shrublands, and that these then mix in to a map of all the ecological communities. And it turns out that Manhattan had 55 different ecosystem types. You can think of these as neighborhoods, as distinctive as Tribeca and the Upper East Side and Inwood, that these are the forests and the wetlands and the marine communities, the beaches. And 55 is a lot. On a per area basis, Manhattan had more ecological communities per acre than Yosemite does, than Yellowstone, than Amboseli. It was really an extraordinary landscape that was capable of supporting an extraordinary biodiversity. So Act 2, a home reconstructed. So we studied the fish and the frogs and the birds and the bees, the 85 different kinds of fish that were on Manhattan, the heath hens, the species that aren't there anymore, the beavers on all the streams, the black bears, and the Native Americans to study how they used and thought about their landscape. We wanted to try and map these, and to do that, what we did was we mapped their habitat needs. So where do they get their food? Where do they get their water? Where do they get their shelter? Where do they get their reproductive resources? To an ecologist, the intersection of these is habitat, but to most people, the intersection of these is their home. So we would read in field guides, standard field guide that maybe you have on your shelves, what beavers need is a slowly meandering stream with aspen trees and alders and willows near the water. That's the best thing for a beaver. So we just started making a list. Here's the beaver, and here's the stream, and the aspen, and the alder, and the willow, as if these were the maps that we would need to predict where you would find the beaver, or the bog turtle needing wet meadows and insects in sunny places, or the bobcat needing rabbits and beavers and den sites. And rapidly, we started to realize that beavers can be something that a bobcat needs, but a beaver also needs things, and that having it on either side means we can link it together, that we can create the network of the habitat relationships for these species. Moreover, we realized that you can start out as being a beaver specialist, but you can look up what an aspen needs. An aspen needs fire and dry soils. That you can look at what a wet meadow needs, and it needs beavers to create the wetlands, and maybe some other things. That you can also talk about sunny places. So what does a sunny place need? Not habitat per se, but what are the conditions that make it possible? Or fire, or dry soils. And that you can put these on a grid that's 1,000 columns long across the top and 1,000 rows down the other way. And that we can visualize this data like a network, like a social network. And this is the network of all the habitat relationships, of all the plants and animals on Manhattan, and everything they needed, going back to the geology, going back to time and space at the very core of the web. We call this the mirror web, and if you zoom in on it, it looks like this. Each point is a different species, or a different stream, or a different soil type, and those little gray lines are the connections that connect them together. They're the connections that actually make nature resilient, and the structure of this is what makes nature work, seen with all its parts. We call these mirror webs after the Scottish-American naturalist John Muir, who said when we try and pick out anything by itself, we find that it's bound fast by 1,000 invisible cords that cannot be broken to everything in the universe. So then we took the mirror webs and we took them back to the maps. So if we wanted to go between 85th and 86th and Lex and 3rd, maybe there was a stream in that block, then these would be the kind of trees that might have been there, and the flowers, and the lichens and the mosses, the butterflies, the fish in the stream, the birds in the trees. Maybe a timber rattlesnake lived there, and perhaps a black bear walked by, and maybe Native Americans were there. And then we took this data. You can see this for yourself on our website. You can zoom into any block on Manhattan and see what might have been there 400 years ago. And we used it to try and reveal a landscape here in Act 3. We used the tools they use in Hollywood to make these fantastic landscapes that we all see in the movies. And we tried to use it to visualize 3rd Avenue. So we would take the landscape and we would build up the topography. We would lay on top of that the soils and the waters and illuminate the landscape. We would lay on top of that the map of the ecological communities and feed into that the map of the species so that we can actually take a photograph flying above Times Square looking toward the Hudson River, waiting for Hudson to come. Using this technology, we can make these fantastic georeference views. We can basically take a picture out of any window on Manhattan and see what that landscape looked like 400 years ago. This is the view from the East River looking up Murray Hill at where the United Nations is today. This is the view looking down the Hudson River with Manhattan on the left and New Jersey out on the right, looking out toward the Atlantic Ocean. This is the view over Times Square with the beaver pond there, looking out toward the east. So we can see the Collect Pond and the Lisbonard marshes back behind. We can see the fields that the Native Americans made. And we can see this in the geography of the city today. So when you're watching Law and Order and the lawyers walk up the steps, they could have walked back down those steps to the New York courthouse right into the Collect Pond 400 years ago. So these images are the work of my friend and colleague, Mark Boyer, who's here in the audience today. And I'd just like if you would give him a hand to call out for his fine work. There's such power in bringing science and visualization together that we can create images like this, perhaps looking on either side of the looking glass. And even though I've only had a brief time to speak, I hope you appreciate that Manhattan was a very special place. The place that you see here on the left side was interconnected. It was based on its diversity. It had this resilience that is what we need in our modern world. But I wouldn't have you think that I don't like the place on the right, which I quite do. I've come to love the city and its kind of diversity and its resilience and its dependence on density and how we're connected together. In fact, that I see them as reflections of each other. Much as Lewis Carroll did through The Looking Glass, we can compare these two and hold them in our minds at the same time, that they really are the same place, that there's no way that cities can escape from nature. And I think this is what we're learning about building cities of the future. So if you allow me a brief epilogue, not about the past, but about 400 years from now. What we're realizing is that cities are habitat for people. It needs to supply what people need, a sense of home, food, water, shelter, reproductive resources, and a sense of meaning. This is the particular additional habitat requirement of humanity. And so many of the talks here at TED are about meaning, about bringing meaning to our lives in all kinds of different ways, through technology, through art, through science. So much so that I think we focus so much on that side of our lives that we haven't given enough attention to the food and the water and the shelter and what we need to raise the kids. So how can we envision the city of the future? Well, what if we go to Madison Square Park and we imagine it without all the cars and bicycles instead, and large forests and streams instead of sewers and storm drains? What if we imagine the Upper East Side with green roofs and streams wending through the city, and windmills supplying the power we need. Or if we imagine the New York City metropolitan area, currently home to 12 million people, but 12 million people in the future perhaps living at the density of Manhattan and only 36% of the area, with the areas in between covered by farmland, covered by wetlands, covered by the marshes we need. This is the kind of future I think we need, is a future that has the same diversity and abundance and dynamism of Manhattan, but that learns from the sustainability of the past, of the ecology, the original ecology, of nature with all its parts. Thank you very much.